Okay, so let's see how well this runs. So this is another follow-up video. Last time you would probably see that I was working on the collision detection and had just got it working, and I left it off noting that there were some slight bug fixes that were needed. And so this update obviously is going to start off with showing that yay, they have been fixed. Before I noted that I could without any fail, I could always replicate having the weird bouncing glitch anytime I was trying to jump onto this upper ledge. Now it works perfectly fine. I can hop around, and that's really great. The other thing I also want to note is what I previously mentioned as a bug of wall grabbing is actually not a bug at all. It's actually the collision detection working perfectly. If you haven't noticed yet, our little character here is a piece of toast. He has like a little line of crust on top of him. So he's actually clinging onto the ledge because that little piece of crust that is sticking out is actually wider than his body, and it is sitting on top of the ledge. So he is grabbing the ledge with his little crust head. So I find that pretty funny. And so I think if I can time this right, there we go, we can also do it in that little notch where his legs stick out. So it's actually because the collision detection is working perfectly. So it's not a bug at all. So that was quite amusing. But for actual fixes, that's all I've actually put in code-wise since then. I really just haven't touched this project in a while. So what I want to do for the rest of this video, though, is actually talk about the collision detection, because I wanted to mention how it worked in the last one, but because it wasn't polished, I didn't feel like it was in a good enough state to really say, okay, this is definitively how it works. I don't know. I felt like it was a bad representation. So if you're interested in that, that's what the rest of this video is going to cover. So with that, I'm actually going to close all of this out because we're actually just going to be going into, well, this is GIMP. It's effectively like Paint or Photoshop. And so I'm just going to be drawing stuff out to show how this works. So first off, what we have is we have ourselves a little dude here, all right? So this is our guy. And now what I'm going to say is, okay, let's have a stage, right? So, right, our game's going to have, like, our levels are going to have stages, right? And then, I don't know, let's draw, hello, little happy balloon boy. Okay, so these are scenes, these are elements in our scene for our game. Now, there's different approaches you can handle for how you decide whether or not they collide. The industry, not industry standard, I would say, but it's one of the most common ones you'll run into is what we'll do is we'll just put like a box like this around our characters. And realistically, actually, how this is coded is it's not necessarily just a box. It's just you're looking at these coordinates for the top left and bottom right corners, and that effectively they define a box. Now, the way that these would work collision detection wise is, let's say we look at, so I'm actually going to label these real quick, and we're going to call this object 1, this balloon boy is object 2, and our terrain is going to be called object 3. I'm probably not going to be too strict on defining that, so it doesn't really matter all that much. But we'll take object 1, and if we want to see if it collides with object 2, what we'll do is we'll look at this top left corner and this bottom right corner in this box. And these are just coordinates that are being stored. If either of these corners are between the corners of our balloon guy here, then the boxes will have to be overlapping. It's just a geometric thing. And so that is the most basic form of collision detection. If you code it efficiently or whatever, it can probably only be like 2 lines of code. So it's really basic and it works perfectly fine. So let's say we are between 2 frames of motion. We have our box boy, our little guy here, and so let's say 1 frame he's going to be here. And the next frame, his collision box, and let's actually change colors real quick. We're going to go into blue and create an, oops. Let's delete that. So let's say 1 frame he's here, and the next frame, his collision box is going to be here. And we'll drop the opacity so we can actually see. So we're moving in a straight line from here to here, right? So the problem is we have here is, right, we can look at these corners. So top left corner, right, it's not between these other 2 corners, so it doesn't collide. We look at the bottom left corner, oh look, it's between them, so we know the box collides, and that's how the computer tells. So now what the computer has to decide is, okay, I can't stick this guy in this range, right? I mean, I shouldn't be able to. So what do I do? So what it does is it says, okay, I'm coming from the left. So that means realistically I should be bumping this thing's left face. So what we do instead is we grab the coordinate for this top left pixel and we say, okay, we're going to set the right edge of our character or our box to be flush against that. And so what winds up happening is we only move part of the distance within that frame, and that's what I like to call collision resolving, is that instead of going the full distance, you're told to say, okay, I can't move that, but I can move this amount. That'll work. So that's what makes these boxes really convenient, is because it's really easy to work with, because again, like I said, we have these boxes predefined, so everything is held positionally. It makes things very convenient. But the problem we run into is what happens if you want a more complex shape. So let's say we want to look at the, oops, I'm just going to remove this and back up a little bit. So let's say we want to look at object 3, which is our terrain down here. So if we want to get a bounding box for it, then what we'll need to do is either we can do some, well, we can't just put a square over the whole thing, right? Because we have curves, we have complicated things. So what we can do is we can approximate it. We can put little bounding boxes around it like this, right? But there are problems with that, because as you'll see already, there are spots where it doesn't quite line up. So if I have a little character that is coming in from the left side to the right, and I bump into this, right? I'm going to be stopped right here, when logically it looks like I can keep moving a little bit, right? And that's kind of a shortcoming whenever defining it in this way. And so what you wind up having to do is have more and more refined blocks. And so the problem I had is that I have to define all of those. Every single hitbox I have to define. So if I'm making a stage, it can be pretty tedious to make that stage. It can run pretty smoothly and it can work pretty well, but it's nonetheless kind of annoying to work with. And so what I wanted to try to do was say, okay, let's take an alternative route. What if I found a way where I can just draw the stage and it's just a PNG file and I have the game figure out how to run that? And so that's what I've been calling per pixel collision detection. I know some other people call it that as well. There might be some other names out there. I can't guarantee it. So the way that this will work is, let's create another person, okay? So we're going to say there's just some dude and he's just enjoying his good old time clipped inside of the stage, right? He's very much stuck. So how do I tell, though? Because I don't want to use bounding boxes. So what I use instead is I look at the individual pixels of each of the images. So in our little dude's case, we start at the top left. And so what we're going to do here is say, okay, let's check every single pixel. We're just going to look over these and see, does this collide with a pixel on an object or an entity? So in this case, no, we're kind of over the air, right? We haven't quite hit the guy. So we're just going to keep going to the right, keep going to the right, keep going to the right, and oh, look at that, we hit him. So we know we have this guy in here. So now what we want to do is check to see if that pixel also is with the stage, if the stage corresponds to that pixel. In this case, no, it doesn't. So we're going to keep going, keep going, keep going until we hit the edge of this dude's image. And actually, we start over here. So then go down to the next line, and we're just going to keep doing that over and over and over until we hit our first pixel where this collides. And so in that case, that's going to be probably about here, I believe. So this pixel right here, and I'm actually just going to circle it, right here is our problem child, right? So this just tells us that it collides, right? And so that's really nice because we're using this case where it's realistically, this isn't where he's at, it's where he's going to be, right? Because he's probably going to be somewhere up here, and then he's trying to move down, but you know, he's moving too far, he's moving too fast within a given frame, right, to be able to do this. So it helps with resolving, or I mean, it helps with detecting, but it doesn't help with resolving, because the problem we have is, since we don't have these friendly collision boxes, it's hard to tell exactly, okay, how do we set him down so that he actually is on the surface better? So let's go ahead and move this guy a little, and so we'll go back in here, and we'll draw him probably like here. Hello, little guy. So what we need to do is we're going to say, okay, we know he's going too far down, and we need to resolve to make sure he's flush on the ground, right? because all we can do right now is we can say, okay, you can't move there in that frame. And so right now, all that can happen is we can just say stop moving so you don't go inside of the wall. But obviously, that's kind of a problem because as we had in our previous bug, if we just say stop moving, well then he's not actually on the ground, he's floating a little, and that can cause some weird interactions. So what we do is, again, we start with his image file, the character's image file. And so, oops, I'm going to try to at least draw like somewhat of a rectangular region. Pretend this is a good rectangle. So we start with his rectangular region, and what we're going to do is, I'm actually going to pick a different color for this next step. We are going to start on the bottom left right below the image. And we're going to iterate over this. So the idea is that we're going to iterate over in a horizontal line all the way down like this, and we don't hit anything yet. And we're just going to do that over and over and over until we hit a pixel below him. And so what that winds up hitting is right here, this pixel right here. So what this gives us is we're going to count how far below that is. And so our loop, we're actually going to do this through nested for loops, actually. So the outer loop is going to be right here, this region here, and that's going to be y coordinates. And we're going to have an inner loop that is iterating over the x coordinates to go horizontally. So our y coordinate is going to be stored in there, and that's just 1, 2, 3, 4, 5, 6, 7, right? So what this tells us right here is that we can safely move down 7 units and still be able to fit. And so that's really nice. And so what we do is we resolve by saying, okay, we have this y position, move this guy 7 units instead of however many he wanted to move before, and that should work. And so that's the resolution we wind up using. It does a pretty good job. It refines it, and we have a resolution for falling. Now, currently for the state of the game, this is the only kind of resolution we have is falling. Because as you can see, we're iterating over a lot of pixels, and as you add more entities that are interacting with the world around it, that can slow things down. So right now, the only resolution that's in there is just for falling. Colliding with walls, well, is still not fixed. So you'll have a case where if we have like a little person right here, and they're moving too fast, they'll just get stopped right up a little bit away from the wall and not be able to move any further because their movement speed is too fast to allow them to actually flushly touch the wall. Now, there's also a few other things we can add in here for optimization, which I wound up using. First off is talking about, okay, which pixels do you iterate over? Because if we're iterating over a lot of pixels, a lot of times, right, we want to make sure we can reduce how many we actually have to check to see if they interact. So, first off, let's look at the stage, right? The stage is going to be massive. This little example of a stage down here as object 3 is completely minuscule. It's pointlessly small. So, in the grand scheme of things, though, the stage is going to dwarf everything else. So, never iterate over the stage. You just code that in, just say never iterate over the stage. So, that's a good option there. So, if we're trying to see if a character iterates over the stage, we just iterate over the character's box. But the question is, how do we tell if 2 characters are colliding? So we have object 1 and object 2 here, and they each have, their own image size. So what we do is we're going to take, so let's just say this is the rough size of the PNG image for the character's sprite, and our little balloon guy is probably something like that, right? So we're going to have dimensions for that. So what we do is we find the one that has the smallest dimensions and we go with that. Now, my implementation is a little lazier. I'm just looking for which one has the smallest x coordinate. So it would iterate over this balloon guy. Realistically, I don't expect to have something that's like really narrow and so tall that it's inefficient to assume it. Everything is roughly like at least closer to a square than an absolute needle. So it's pretty safe to assume that if it has a smaller x value, then its area is also going to be smaller. And then we have one last optimization that I'm using that actually isn't from per pixel collision detection. So I was saying I'm using per pixel collision detection as a replacement for the hitbox, but it's not actually true. I'm using it as a refinement for the hitbox, because what actually I'm using is, what I'll do is I will put a hitbox over the characters, but they are very, very generous hitboxes. Something like this. And so, as you can see, these are cartoonishly far apart from the actual characters. But the purpose of them is not actually to resolve collisions. It's to see when do I actually have to do per pixel collision detection. Because as you would assume, per pixel collision detection is a lot more math and a lot more processing power than this regular bounding box. But it's very precise, it's very accurate because it's looking at the actual pixels. So what I do is I try to reduce how often I actually have to go to per pixel collision. Because as you can see, we have these boxes here, and if we were to have these corners, right, you can see these corners are not inside of each other's box, right? These guys are perfectly fine. So if I have this generous box and I could just do a very quick check to say, wow, these guys are very far apart, they are not colliding, there's no way they are colliding, then I don't run the per pixel collision detection. And so that actually saves a lot of the processing pain that you can wind up running into with the per pixel collision detection. The only problem that I generally wind up running into is that, well, you either have to have a hitbox that is just the entire screen for the stage, or you do what I do and I say the stage doesn't have a hitbox, and I run a special condition where if there is no hitbox, then do per pixel anyways. And so the stage is always running per pixel collision detection over any hitbox stuff. There's no hitbox checking for that, but that's all right. And so that's pretty much the gist about how this stuff kind of works, or specifically how this has all been implemented. It's definitely really cool. It's something I really liked working on and building, and this is pretty much to the extent of what I have right here. Now, there's obviously other cool things I've built, and so I'm kind of using this as a testing run to see how well or how much people like hearing the ways I've implemented these. Because I mean, working on this project has been a bunch of fun, but generally when I've been uploading these videos, I've mostly only uploaded them for the purpose of documenting for myself, and I didn't really actually expect people to watch them. But I've been getting comments on them, and they're from people who I don't actually know. So I mean, some people have been finding them and they've been liking them. So if you're interested, I'm actually considering at this point just going through and showcasing how some of the mechanics work in this more generally like this. I'm a little apprehensive to showing actual code. I like the idea of keeping things generalized enough that you could apply it to different languages, but at the same time, I understand finding projects like this is also how people get interested into programming and how they actually, start learning the language itself and really buckling down and getting to it. So I at the same time, I might also still just show some code for people who are learning Python for the first time. So that's where I kind of leave it as an open end here. If anybody is interested or would be interested in something like that, I'd be perfectly down to creating a series like that. It's just, again, I'm probably not going to go through the effort if nobody really wants it. So there we go. Hope you enjoyed all of this. I'll try to have another update out in a little bit. I don't know, though. I'm not quite too sure what to work on yet.